Okay, can you make out all the teeny letters? That is a lot of G's and C's and A's and T's. The human genome is comprised of nucleotide bases coupled into base pairs, and the nucleotide bases are given these letters as an abbreviation. They stand for guanine, cytosine, adenine, and thymine, and they're coupled into those respective base pairs, one of two. So it's a binary code like ones and zeros for computer programming. So on this page I have put, and I'm walking through this with you so that it's totally verifiable, 305 by 393. So you could reproduce this. Got about 120,000 alphabetic letters, but like I said, each pair is a letter of binary code. So I divided that in half. Now I've printed both front and back to be compact. So let me multiply it times 2. I just did that, got back to the original number. That's the number of letters of binary code on that sheet. That's a large number, not nearly as large as I'm after though. So this ream has 500 sheets of paper. So if I multiply that times 500, I get a larger number, 60 million letters, but not nearly large enough. So here's a box. You can see from the number of sheets in it that it contains 10 reams. So let's multiply that times 10, get us up to 600 million, which is a big number, but not what I'm after. So I've got here 11 boxes. And so if you had that code this size, multiply it times 11 boxes, those 11 boxes of it, now you get the number I'm after, 6.5 billion. So the human genome, not in haploid cells that are only used for reproduction and only have a single copy of the chromosomes, but normal diploid cells that your body is made of and has trillions of. This is how much information is in the nucleus of each of those cells in the DNA molecule. It's an outstandingly large code. It's enormous. Illustration I could think of is, imagine this was the instruction manual for your garage door opener and you had to find out how to reprogram the downstop. So I pity the person who has to find somewhere in all of that where that part of the code is. Another way to think of it is through a rate. And I don't mean to condone things that violate the laws of physics are impossible. It doesn't matter how fast or slow they supposedly occurred, but just to give it another illustration of perspective, you'll find people that claim the Earth is 4.5 billion years old and that life started evolving 3.5 billion years ago. And you'll find differing numbers for that. And they keep getting larger and larger for psychological reasons. But let's divide that by 3.5 billion years, and you find that that's every 2 base pairs every year. So consider this, that a letter randomly created through a mutation, rejected because it's bad, randomly created, rejected, created, rejected, created, rejected, created, rejected. It's random, purely random after all. So I don't know how many times that has to happen before there's a good letter through just sheer luck, obviously a lot. But anyway, and finally after, I don't know how many iterations, a letter that's actually good and locked in, and then needs to be propagated uniformly throughout every creature in the entire planet so that they now all have this new letter and none of them don't have it. So what I just described there, imagine that happening at an average rate of speed of once every 6 months, all of that happening. So that just mind-bogglingly fast lightning speed that the genome supposedly created itself gives you some kind of idea, as well as this visual one, of how truly enormous that code is, the human genome.